Hello, and welcome to today's video. Have you ever wondered how the sun burns so brightly if fire needs oxygen to exist? If that question has crossed your mind, you're not alone. Many people think of the sun as a giant ball of fire, but that's not quite accurate. The sun's process of producing light and heat is completely different from the kind of fire we're familiar with on Earth. In this video, we'll dive deep into the fascinating science behind the sun's energy production, why it doesn't need oxygen, and how it sustains itself for billions of years. Let's get started. What is fire, and why does it need oxygen? To understand why the sun doesn't need oxygen, we first need to understand what fire is and why oxygen is essential for it. Fire, as we experience it on Earth, is a chemical reaction known as combustion. This process occurs when a fuel reacts with oxygen, producing heat, light, carbon dioxide, and water as byproducts. For example, when you light a match, the heat from friction ignites the chemicals on the match head. These chemicals react with the oxygen in the air, sustaining a flame. Without oxygen, combustion cannot occur, and the fire goes out. This dependence on oxygen is why we associate fire with the need for air. But the sun isn't burning in the same way a campfire or candle burns. Its energy production is a completely different phenomenon called nuclear fusion. How the sun produces energy. The sun is not a giant fireball fueled by combustion. Instead, it's a massive sphere of plasma powered by nuclear fusion, a process that takes place at its core. What is plasma? Plasma is often referred to as the fourth state of matter. It's similar to gas but consists of free electrons and ions due to extreme heat and pressure. The sun's core is so hot, around 15 million degrees Celsius, 27 million degrees Fahrenheit, that it exists entirely in this state. What is nuclear fusion? Nuclear fusion is the process by which atomic nuclei combine to form a heavier nucleus, releasing enormous amounts of energy in the process. In the sun's core, hydrogen nuclei protons fuse to form helium nuclei. Here's a simplified version of the process. Two hydrogen nuclei collide with enough energy to overcome their natural repulsion. They fuse together, forming a heavier nucleus and releasing energy in the form of light and heat. This process repeats billions of times per second, producing the immense energy that powers the sun. This process doesn't rely on oxygen because it's not a chemical reaction like combustion. It's a nuclear reaction, driven by the immense gravity and heat at the sun's core. Why the sun doesn't need oxygen. Now that we've explored nuclear fusion, it's clear why the sun doesn't need oxygen. Nuclear reactions vs. chemical reactions. Unlike combustion, which requires oxygen, nuclear fusion involves changes in the atomic nuclei of hydrogen atoms. The energy release comes from the conversion of mass into energy, as described by Einstein's famous equation, E=mc². Self-sustaining energy source. The sun's immense gravitational pressure ensures that hydrogen atoms are constantly compressed and heated, sustaining the fusion process without the need for an external reactant like oxygen. Composition of the sun. The sun is primarily composed of hydrogen, about 74%, and helium, about 24%, with only trace amounts of other elements. There's no significant oxygen present to participate in combustion, even if it were required. How long will the sun last? The sun's ability to produce energy through nuclear fusion is not infinite. It has been shining for about 4.6 billion years and has enough hydrogen fuel to continue for approximately another 5 billion years. Over time, the sun will exhaust its hydrogen supply and begin fusing helium and heavier elements. This will mark the end of its main sequence phase and lead to its transformation into a red giant, and eventually, a white dwarf. Common misconceptions. Many people think the sun is burning like a giant flame in the sky. This misconception arises because the sun emits heat and light, much like fire does. However, understanding the science of nuclear fusion helps us appreciate the sun's unique nature and its crucial role in supporting life on Earth. Why understanding this matters. Understanding how the sun produces energy helps us appreciate the scale and power of nuclear fusion. Develop technologies like nuclear fusion reactors, which could provide clean, abundant energy on Earth, better understand the life cycles of stars and the broader workings of the universe. The sun's energy production is a testament to the incredible power of nuclear physics. Unlike fire on Earth, the sun's light and heat come from nuclear fusion, not combustion, and it doesn't need oxygen to shine. By exploring this topic, we've not only answered a fascinating question but also gained deeper insight into the processes that sustain our solar system. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating science content. Let us know your thoughts or questions in the comments below. Thanks for watching, and we'll see you next time.